To our next discussion, we're sort of broadening our view, and we're going to hear from some experts on the global developments in hybrid power for mines. And it's my pleasure to introduce our first presenter. Dean Tuel is currently the Vice President of Sales for Aggreko Microgrid and Storage Solutions. And he's responsible for the Americas and AusPac regions and has over 25 years experience in renewable energy projects.
So, thanks for inviting me over here. I appreciate it. I actually bypassed Father's Day just to spend my time with y'all. Fortunately, my 10-year-old son left this in my bag. It's a little card. And he reminded me when I got over here to help save the world. And so part of my job is to kind of do that. What a lot of people here may not know is usually people think of Aggreko more as a traditional rental solution for thermal generators and cooling units. About a year and a half ago, they acquired a company called Unicos. Unicos was principally a battery storage company that also was involved in a number of microgrid projects. So just a little bit about us. That, like I said, we were acquired about a year and a half ago. The company's been around since early 2000. We've developed projects all over the world, roughly 50 individual battery storage projects, including several microgrid projects. And those range in sizes from 1 megawatt all the way up to 49 megawatts. Part of the reasons why I came in here was to try and give you all a little bit more of a global view about some of the projects that we've been involved in with mines, and part of what goes into that is a team of people, roughly about 130, 40 people. They're spread out across Berlin, Austin, Texas, where I'm from, the great state of Texas. One thing you should know about people from Texas is it usually only takes about 4 seconds for us to tell you where we're from. Then we've got a few people in London, which is where our principal executive leadership sits. This is one of our key products. Was recently launched, although we've had variations on the Y-Cube for some time. It's essentially a 1 megawatt block. Comes in 30-minute durations, 60-minute durations. Earlier today, somebody had mentioned something about the cost. I think it was roughly $185 a kilowatt hour. What's important to note about battery storage that a lot of people don't connect unless they've been a part of it for some time is that $185 only referred to the cells themselves, only the batteries. So in this picture, that would just be those cells. These are actually Samsung cells in the back there where you see that sleeve kind of pulled away. There's a lot of other equipment that goes in there. There's cooling equipment, fire suppression equipment, there's an enclosure, there's software, there's other things that help to make it work. So usually that price point, depending on the duration, comes up to around $400 a kilowatt. So what does that mean? It can vary if I want to add an hour duration or a 2-hour duration or a 3-hour duration battery. So that price goes up and down. And one of the beauties, there was an earlier quote by Elon Musk. Several years ago, he had given a price point of around that $400. And I can tell you, we were around $600 at the time. And within months, we started stripping things away. We started finding things, right? I'll also note that we have personally beat Tesla in several projects, but the guy has been instrumental in helping us get to those price points. Another key feature to our business strategy, which I think is important, and I'm going to talk about that within a couple of projects I'm going to mention, is that we are integrating in both solar, integrating in the battery. The battery often is used as an enabler to the solar component, and I'll show you a little illustration about how you can see that you can increase that penetration more and more as you add more batteries. But we also want to do it at an economic cost that isn't a disadvantage to the mining site. And this applies actually across all sectors that we look at. The other thing that I want to mention is we'll do standalone batteries. We'll often come in and put in batteries as a part of an existing project, but a lot of the projects I'm going to talk about today are either in early phase development, and some of them are currently operational, and that'll be one of my latter ones I talk about. But the other thing is, one of the things that Aggreko does that I think is really unique is we will fully wrap that solution. So a lot of the conversation that was out here earlier today highlights some of those very same components. We'll come in, we'll balance sheet the power supply solution ourselves, which means the warranties on those batteries, the warranties on those solar projects, everything that goes into the various pieces of equipment, we'll simply stand in for that and provide a performance guarantee. We'll say that it will operate to the standards you want to. We will make it a low CapEx operation to you and push things closer and closer to the variable cost with perhaps a capacity fee on a monthly basis. And we can do that under shorter terms. There's some exceptions to that. Solar does usually only make sense when it goes beyond a certain time period. And we can talk about that a little more later on as well. So to talk about some of the projects that I want to highlight, earlier Graham had talked a little bit about the Granny Smith project. This is it. This is one of our flagship babies. I'm not going to dwell into it too much, other than to mention that we're coming into this project. We are fully wrapping it. The BESS itself is in fact enabling the solar to penetrate more. So the solar itself won't become fully operational until the battery storage system is there. That's all expected to happen between end of August to October of this year. Part of the functionality of the battery storage is it's going to help smooth out the production profile from the solar. So rather than you see a profile that looks like this, you'll start to see it become a little bit more smooth. And that helps prevent some of the issues that would otherwise happen, thereby making the battery storage one of the things that increases the reliability of the system. And this is probably one of the key things we have issues with that I see when I'm talking to mining companies, frankly, 5-6 years ago, even with utilities, about whether or not solar and batteries make sense, was they were all concerned about reliability. I can assure you that battery storage is not a lab experiment anymore. There's so many projects out there where we can show you the data. In fact, we've got data that goes back to the early 2000s that will validate that these systems perform to that very standard. This next project that I have here is based in Argentina. This goes back to the spinning reserve story that a number of people have talked about earlier. On this graph, you'll see the blue line, which is where the thermal generation was operating, its load factor was operating without the battery. By putting in the battery, we simply allow the units to be able to operate more in their sweet spot, and it's a simple economic story where we're reducing fuel. And this is a real basic project where we'll come into an existing operation, we'll add a battery, we'll reduce fuel consumption, and essentially this project will save the customer roughly about $100,000 to $200,000 a year. This next project, this is in Mexico. We're going to be integrating both battery storage, but it'll have two applications. The spinning reserve application that I talked about before. The graph on the right has a very similar, is supposed to display very similar characteristics of what I talked about prior, where we're simply increasing the loading on the generation so that we're reducing fuel consumption. The chart on your left, you'll see these little blips where I've got some red circles. That's where we have periodic startup of equipment. And what we're doing is we're using the battery to help start that equipment. So we don't have to add another genset in so that that genset is being used to start that equipment. Here again, we're just saving fuel. The other component that we're adding to this project is solar. So we talked a little bit earlier about the term and whether or not solar makes sense under 5 years. And I can tell you that generally is a challenge. because you're talking about a fixed cost of an asset, and you're simply taking the throughput of that asset, and you're able to stretch it out over a longer period of time. So I gave some examples at this particular location, and this happened to be data that we derive from PV Assist, which gives us exactly what the expected generation of this particular design of the PV was. And you'll see some of the sample prices, and these are in US dollars. It's a fairly high radiation area of the country, but in 5 years, we're talking about $120, all the way down to a 20-year PPA at around $70. This does vary depending on the size. So in this case, the project was about 7 megawatts P of solar. So as we get a larger scale project, we also see these numbers change. We get more or less radiation. We're looking at some projects up in Canada where obviously during January and February we're not getting the same sort of sun that we would otherwise. So we're going to see sort of a little bit more or less of a balance between how much space we have, how much solar panels we can put on the ground, and what sort of penetration we can get. So this is another existing project that we have in Africa, where there's been solar that's been added to the site. It's a diesel generation run project. The solar was initially put in to go ahead and help reduce the cost of energy. But now, as the system started to become more and more operational, we're starting to get more operational history on it, we're looking at whether or not we can add more solar to the site. The graph down here at the bottom shows you, as we add more batteries, how much more solar we can add to the site, thereby adding that penetration of renewable energy, which has a very low variable cost, right? And so we can help lower the LCOE on the project. And we see this with every project. So you'll see as we go down that chart on the left side, you'll see as we get to 5 megawatts of batteries, and you go over to the right side, you can see where we're adding penetration. We're getting up to about 35% of penetration of the solar as a component of the overall project. So it can be pretty significant. Although the environments out here, we're also facing issues where the panels themselves periodically get dusting, so we have to maintain them in a different way than what we would in another environment. This is a project in Brazil we're looking at. This happens to be one of the few ones that we've looked at that is grid connected. So a different application, a different geography. In this case, we're going to use the battery to simply reduce the max off-peak demand and the max peak demand of the project. And so you'll see on the graph on the right where we're shifting down by adding a 3 megawatt battery. We're going to move that demand down slightly, and what it does, it has a direct impact on the time of use tariff that they're charged from the utility company to supply their energy, and it's going to save roughly $930,000 a year. That does not include the full cost of the batteries. I'm trying to compare apples to apples, but I can tell you that there is an overall net benefit if that solution was provided by us. So hopefully that gave you a little bit of different perspective. I am the power supply guy, right? We do have a lot of global reach. Certainly, I tried to give you all a flavor for not just different geographies, but different applications about what batteries and solar can do. And then how we, as Aggreko, how we can come in and wrap that entire solution, provided a low CapEx opportunity for you to focus on doing what you do normally, which is mining. Thanks for your time.